What does getting the flu have to do with a melting ice cap? I know, it sounds a little out there, but what if I told you they both follow the same hidden rule? Today, we're going to connect two things you've probably never put in the same thought before: the health of your body and the health of our planet.
So yeah, let's just ask it directly. What on earth could getting sick possibly have in common with the climate crisis? I mean, one is this super personal battle with a tiny virus, and the other is a massive global challenge we measure in degrees and decades. But believe it or not, they operate on the same fundamental principle.
And the answer? Well, it pulls back the curtain on this hidden rule about how really complex systems, any complex system, breaks down. This isn't just a cool metaphor. It's a critical concept for understanding our world, and honestly, understanding it has never been more important.
Okay, to get our heads around this, let's first zoom way in. We're talking microscopic level. Let's talk about the incredible battlefield inside your own body.
We all throw around the word immunity, right? And at its simplest, it's just your body's amazing ability to fight off invaders, like a virus. But how it actually does that, that's where things get really fascinating.
Now, don't worry about all the complicated labels here. Just look at the web of connections. Your immune system isn't some simple fortress wall. No, it's a dynamic, constant balancing act. All these different parts are chattering back and forth, sending signals to either ramp up the attack or, just as importantly, to calm things down. It's all about keeping things in equilibrium.
And here is the absolute key. When a virus gets in, it starts pushing on this system. And depending on things like how fast that virus is copying itself, the whole system can end up in a totally different place. One place is, full recovery. But another very different place is chronic illness. It's the same system, but the outcomes are worlds apart.
All right, you ready? Let's zoom all the way out. From that microscopic battlefield in your body to the one we all share, planet Earth. And just like your immune system, our climate is another one of these incredibly complex, deeply interconnected networks.
For years, scientists have been giving us a number: 1.5 degrees Celsius. That's the amount of warming we want to stay under compared to pre-industrial times. And this isn't some random goalpost. It represents a critical threshold for our entire global climate system.
Now, you might be thinking, what's the big deal about half a degree? It sounds tiny. Well, according to the UN's top climate scientists, it is a massive deal. At 1.5 degrees of warming, we're looking at about 10 centimeters less in sea level rise compared to 2 degrees. And get this, at 1.5 degrees, around 14% of us will face extreme heat waves. But at 2 degrees, that number jumps to over a third of the entire human population. That tiny half a degree has absolutely enormous consequences.
So what's the thread connecting a virus that overwhelms your body with a planet that's heating up? We've been circling around this single, incredibly powerful idea. It's called a tipping point. It's that terrifying moment where a system that's been under a lot of stress doesn't just bend a little more, it snaps. A small, seemingly minor push crosses a hidden line, and boom, everything changes. Suddenly, and a lot of the time, permanently.
This is exactly what can happen inside our own bodies. Studies show that if a virus starts replicating just a little bit faster, just enough to cross that critical threshold, your sickness doesn't just get a little bit worse, it can suddenly spiral, tipping your body into that chronic state we talked about. A tiny change in cause, a massive change in effect. That's a tipping point in action.
And this graph, this shows the exact same danger, just on a planetary scale. See how that business as usual line isn't straight? It curves up, and it gets steeper and steeper. That's what happens when a system gets pushed past its tipping point into a new, much hotter, and frankly, much more dangerous state of being.
To make this risk feel a little more real, a climate action report posed this question. Think about it. Would you get on a plane if you knew there was a 1 in 20 shot of it crashing? Of course not. No way. Yet with climate change, we are rolling the dice with these low-probability events that have catastrophic, world-altering consequences.
Okay, so if these incredibly complex systems can be pushed past a tipping point for the worse, can they be pushed back? This is where we get to the idea of intervention, of finding and pulling the right levers.
And you know what? Whether you're a doctor or a climate scientist, the playbook is basically the same. First, you have to truly understand the complex web you're dealing with. Then, you figure out the most sensitive parts, the spots that have the biggest influence on everything else. And finally, you design smart interventions that act on those spots, like powerful levers. So for our climate, this diagram lays out the major levers we have. You've got the big one,
decarbonization, changing how we make energy. Then there's a faster-acting one, cutting pollutants like methane that have a powerful short-term effect. And then there's a more future-focused one, literally pulling carbon back out of the sky. Each one is a different tool for a different part of the job.
And it's the exact same logic in medicine. Doctors don't just throw random drugs at a disease and hope for the best. No, they design these incredibly specific tools, like monoclonal antibodies, that are engineered to be a precise lever on one specific part of that complex immune network we saw at the beginning. It's all about smart, targeted intervention.
So where does all this leave us? We've seen how our bodies and our planet both kind of live on a knife's edge as these complex systems that can be tipped over. So what's the big takeaway here?
It's this. This is maybe the most important rule when you're dealing with systems that have tipping points. It is always easier to stop the system from tipping over in the first place than it is to try and push it back upright after it's already fallen. Acting early isn't just a good idea, it's exponentially more powerful.
So I'll just leave you with this final thought. A fever. It's your body's early warning system. It's screaming at you that the system is under stress, and we listen to it. We act. Right now, our planet is running a fever. The science is telling us it is getting dangerously close to its own critical tipping point. The only question left is, are we going to act?